Hi everyone. So in this video I'm going to show you how to factor using the factor tree method. There are other methods that are perfectly valid. This is just one method, but this is a good method and it's a method that always works. Okay, so I'm going to use 120 as my example to factor with the factor tree. I'm trying to get it into its prime factorization. That is a list of numbers where all of those numbers are primes, and when you multiply them together, you get 120. So first I'm going to just do it the way I personally would do it. This 0 jumps out at me with the divisibility rule that any number that ends in 0 is divisible by 10. So I am immediately dividing by 10. Now I know that when I divide by 10, all I need to do is knock off the 0. So if I knock off the 0, I'm left with 12. In other words, 10 times 12 is 120. So that was easy. Okay, next, 10. Now, I know 10 is 2 times 5. You probably have that down too, and if you don't, you will pretty soon. 2 times 5 is 10. So that was simple. I've got my 2. Whoops, I didn't mean to erase it there. My 2 and my 5, those are both primes. Okay, you don't have to circle them at the bottom, but sometimes I like to do that. Now, 12 is 3 times 4. That just jumps out to me. You know, you could start thinking through, well, what are all the numbers that go into 12? Or you could use some of these divisibility rules. You could look at the divisibility rule for the number 2. If it ends in an even, then it's divisible by 2. So I could have, for example, divided this and had 2 and 6, and then divided the 6 into 2 times 3. But I happen to go straight to 3 times 4, okay? Doesn't really matter. That's what I did. 3 is a prime, so that branch is complete. 4 is composite. It's not prime, so I can keep going. Now, 4 I know is 2 times 2, and those are both primes. All right, so at the end of every branch, I have a prime number, and this means that 120 equals 2 times 5 times 3 times 2 times 2. Or I'm going to arrange it in numerical order. Lowest is 2. We have 2 times 2 times 2. 2 times 2 times 2 times 1, 3 times 1, 5. Okay? And if we multiply that back out, we'll get 120. Some people like to write this as 2 to the exponent of 3 times 3 times 5. That's also totally legitimate. We have 2 times 2 times 2. That's the same as 2 to the exponent of 3. This is just an alternative way of writing the prime factorization. Okay. Now, if you do a prime factorization for a number, you will always get the same answer at the end, provided that you didn't make any mistakes. So let me come back here now and take this 120, and let's suppose that I don't notice the 10 right off the bat, and let's suppose I'm just starting left to right here. 2. Is it divisible by 2? Well, it is, because 0 is even. So if I divide it by 2, well, now here I might have to actually do long division. That's okay. How many times does 2 go into 1? It doesn't. So I look at the 12. How many times does 2 go to 12? 6 times. 6 times 2 is 12. Subtract 0. Bring down a 0. How many times does 2 go to 0? 0 times. 0 times 2 is 0. Subtract, I get 0. So I'm done. So we have 2 times 60 is 120. 2 is prime, so it's done. 60 now. Is it divisible by 2? It is. It is 2 times 30. 30, is it divisible by 2? It is. It's 2 by 15. And 15, well, that's 3 times 5. Okay, so that tells me that 120 is 2 times 2 times 2 times 3 times 5. Exactly what we already have over here. Okay, so it doesn't matter how you do it, as long as you do everything correctly, all your steps, you will end up at the same prime factorization. In fact, the prime factorization is unique for each number. Each number has exactly one unique prime factorization. Now let me just, I'm going to do it a few different ways just to show you the variety. Let's take, I don't know, let's suppose I'm curious about 8. Okay, what's the rule for factorability by 8? Well, 8 is 2 times 2 times 2. So we look at the last 3 digits and see if it's divisible by 8. Well, that's kind of silly. This is only 3 digits, but whatever. I'll take that and I'll see, can I divide 8 right into 120? Well, 8 goes into 1, no times. 8 goes into 12 once. 1 times 8 is 8. Subtract, I get 4. bring down a 0. That was kind of funny the way the pen did that. We get 4, bring down a 0. How many times does 8 go into 40? 5. 5 times 8 is 40. I subtract and get 0 remainder. So that means that 120 is 15 times 8. Okay, neither of these are prime, so I can keep working on both branches. 15, that's 3 times 5. Those are both prime, so that part is complete. 8, well, that's 2 times 4. 2 is a prime, so that's complete. 4 is 2 times 2. So there we go. And once again, I get that 120 is 2 times 2 times 2 times 3 times 5, just like I've got out there. Okay, should we do it one more way? Why not? Let's suppose we start with, I don't know, 5 maybe. Maybe we see this 0 at the end and we say, hey, I know the divisibility rule for 5 says that if I'm dividing by 0 or 5, if the last digit is 0 or 5, then that number is divisible by 5. Okay, so I'm going to start off with 5 then. 5. Now, I better use a little bit of long division here to divide this. 5 goes into 1, not at all. 5 goes into 12 twice. 2 times 5 is 10. 12 minus 10 is 2. Bring down the 0. How many times does 5 go to 24? 4 times 5 is 20. Subtract 0. There's no remainder. So in fact, if 5 fits into 120 24 times. 5 is a prime. 24 is not. Okay, now there's lots of options here, right? I could say 2 times 12. I could say 3 times 8. I could say 4 times 6, right? I could say 6 times 4. I could do it the other way around, or 8 times 3, or 12 times 2. Let's say the first thing that pops into my head is 6 and 4. Okay, composite, composite. So both are going to be broken down further. 6 is 2 times 3, and those are both primes, so that part's done. And here's 2 times 2. And since we have only primes at the end, we have once again that 120 is 2 times 2 times 2 times 3 times 5. Exactly the same answer again. There's how we use factor trees. If you don't know the divisibility rules, I do have another video on that. Go find my video on divisibility rules, and that'll help you out too.